we're on lesson 4.2.2. It's going to teach you on how to use a tree diagram. So far you've learned a few probability models, and so in this methods and meaning box is kind of an organization of all the different tools you have at this point. So there's this area model, which is this first one. The area model is this picture of rectangles, and there's a tree diagram that we're going to go into further details today, that kind of show you what each branch of probability is. Okay, all right, so let's go ahead and start. First problem here says you're challenged to a spinner game. The first letter comes from spinner 1, so spinner 1 is right here, and second letter comes from spinner 2. If the letters can form a 2-letter English word, so if the two combine together, it forms an English word, you win. Right? So are the outcomes for spinner 2 independent of the outcomes on spinner 1? So whatever you spin on spinner 1, does that affect your result on spinner 2? No, because they're two different spinners. So they're independent, right? So they don't affect each other. So are they independent? Your answer is yes. Independent. It's two different spinners. Okay, so it says now make a probability area model of the same space and find the probability that you will win this game. Okay, so what does this mean? So it's saying that you're going to list your possibilities for spinner 1 and list your possibility for spinner 2 and look at the probability of the two of them combined, right? So I would go spinner 1 across because there's 3 of them across that way. So this is spinner 1, and you have I, U, and A. Now, it tells you exactly down here what is the probability for each one. So probability for I is a half because it's half of the circle. Probability of U is 1/6, and probability A is 1/3. Okay, how about on the side? So you might want to turn your paper sideways. This is spinner 2, right? And I have 2 letters here. I have, oopsies, I have T and I have F. Excuse me. The probability of T is 1/4. Probability F is 3/4. Okay, so then what will you get? You're going to combine these 2 letters together, right? So you will get I and T, IT. I get UT. I get AT, IF, UF, and AF. All right. Now, what is the probability of each of these? You then need to multiply the top with the across. So the first one, I'll multiply 1/2 with 1/4. So I get 1/8 because 1 times 1 on the top, 2 times 4 on the bottom. The next one, I have 1/4 times 1/6. So I get 1/24. And then 1/3 times 1/4, I get 1/12. Next, I have 3/4 times 1/2. So you get 3/8. And then I have 3/24, which really should reduce down to 1/8, right? So when you can, you want to reduce your fractions. And the last one, you get 3/12, which becomes 1/4. Okay. All right, so here is the probability of each of these, right? So find the probability you will win this game. So which one of these make actual English words? Well, it, at, and if. All right, so these are the true English words. And so what is the probability you'll win this game? You then take your probabilities and add them up. I have 1/8 plus 1/12 plus 3/8, right? So for me, I would probably add these 2 up first because that gives me 4/8, and that's 1/2. Then I go 1/2 plus 1/12 and change this to 6/12. That's 1/2 as well, plus 1/12. So my final probability is 7/12. That's very good. It's over 50%. You have over a 50% chance of winning this game. Very nice. All right. So is this game fair? Is it fair? Do you have equal likely chances of getting things? No, because the regions are not even, right? If the regions are all even, then this game is fair. If you play this game 100 times, who will win more? Who will win more? Let's see. You will win more because if you get a 2-letter English word, you win and you have more than 50% chance of winning, right? Because your winning chance is 7 out of 12. So we'll talk about it in a minute. First, answering the question, is this game fair? I would say no. The regions are not even, right? And the probability is not even. You have 1/2, 1/6, 1/3, so they're all different. Next, if you play this game 100 times, who will win? Okay, so what you need to do now is take your probability. So I take my probability of 7 over 12 and multiply by 100 to see how many of those will be my winning times, right? So my winning chance is 7 out of 12. And multiply by playing 100 times, that will give me 58.3. So out of 100, I will win 58 times. So win 58 times. Therefore, who wins more? Me, right? You. It says you will win, so you win, right? All right. So that's how you deal with the area model. I believe you saw a little bit of this throughout the chapter, and most importantly in the last lesson. So hopefully this is not something brand new. Okay. All right. Can we model the same game using a tree diagram? So why is this tree diagram misleading? So it goes from these three, I, U, A, right? And then from the I, U, A, for spinning I, U, A, you can then spin T or F, T or F, T or F. Why is this diagram misleading? Because it looks like you have equal chances of going any direction because they're all the same length and they're all the same weight. So it looks like equal chances. But is it truly equal chances? No, because you have way more chance of getting the I than any other letter because I take up half of your spinner, right? So it looks like equal chances, but not true. So what can you add so we can reflect this probability? We can add the probability to each branch. Meaning that, okay, I can draw this tree. It's totally great. It's totally useful. But now I need to know what are the chances, right? So chances for I is 1/2. The chances for U is 1/6. Chances for A is 1/3. And then the chances for T is 1/4. F is 3/4. So I am putting these numbers on the branches themselves so that when you are calculating the probability at the very end of the branch. So for example, don't do this, but for example, if I'm going this branch and then this branch, I need to multiply 1/2 with 1/4, hence giving me the probability of that to be 1/8. Okay, so you got to multiply each of the branches. If I were to go to the next branch, 1/2 and 3/4, that would give me 3/8. Okay, so you don't have to highlight what I'm doing because you got to keep erasing, but you need to figure out all the probability in each of the branches. So I go 1/6 times 1/4, that's 1/24. 1/6 times 3/4, that's 3 over 24, which is 1/8. Next branch, 1/3 times 1/4 is 1/12. And then last branch, you have 1/3 times 3/4, which is 3 over 12, which makes it 1/4. Okay. All right, so we should have the same exact probability as before, just a little bit organized a little bit differently. So now it says, what is the probability of spelling the word at, right? So you go down the branch A, T. What is the probability? 1 out of 12. So you got that by taking 1/3 times 1/4 to get 1/12. Can you find the probabilities of the other combinations of letters? Yes, we already did. I already made you do it, so it's already there. So what is the probability you will spin the word? Okay, so let's see, what are some words? At is a word. If it is a word. If is a word. And I don't think there's any more. So we're going to take all those probabilities, 1/8, 3/8, 1/12. So 1/8, 3/8, 1/12. Remember, same trick as before. I can add this up to be 4/8, which is 1/2. So 1/2 plus 1/12. I'm going to make that 6/12 plus 1/12, giving me 7/12. Does this match your answer in the previous? Yes, they're the same thing. Just because it's a different diagram doesn't mean you will get different answers. It still organizes the same thing as before. Okay? All right. Let's move on. This is one of my favorite problems. It says, Ryan built a maze with a floor plan shown below for his pet rat, Romeo. All right. In addition, he placed some cheese in an airtight container in room A. So remember, it's airtight because you don't want him to have the advantage of smelling it. He's just blindly going through this, right? Suppose every time Romeo reaches a split in the maze, he is equally likely to choose any of the paths in front of him. Calculate the probability that Romeo would end up in each room. Okay, so you can use the diagram in front of you, or you can redraw the tree diagram. This is a tree diagram. So what Romeo is doing here, I'm at this fork right here. He has 1, 2, 3 choices. So I have 3 branches. 1, 2, 3. So he has a third chance, 1 out of 3 chances at every single branch. Sorry. Then at this fork here, he has 1, 2, 3. So same thing at this fork, he has 1, 2, 3. So 1/3, 1/3, 1/3 again. Okay. As he goes in, all right, he's done there. It goes all the way to room A. All right. So this goes in room A. This branch right here, it ends in room B. This branch right here also ends in room B. This branch right here ends in room A. Okay, last one. I'm at this branch here. He has 2 branches to go. So he can go left to room A and right to room B. So because there's 2 branches, he has 1/2 of a chance to get in. Now, let's figure out how are his chances at each branch, right? So same as before, if I were to figure out the first branch, I'd go 1/3 times 1/3. 1/3 times 1/3 gives me 1/9. Okay, so you got to do that for every single branch here. I'm trying to erase just my highlight. Thank you. I do every single branch here. So 1/3 times 1/3, he has 1/9 again. 1/3 times 1/3, 1/9. This one's just straight 1/3 because there's no second branch to that one. And then 1/3 times 1/2 is 1/6. And then this is 1/6 as well. Okay. So he is equal. Calculate probably that Romeo will end up in each room. So you got to look at room B and room A. All right. So room B, actually, let's go in order. Room A is here. 1/9, 1/3, 1/6. So 1/9 plus 1/3 plus 1/6. Okay, so you can use any method you want. I usually just go ahead and add 2 of them at a time, or you can look at the fact that these are all common factors. You can find a common denominator, right? If you make all of them 18, it'll work beautifully. So if you make all of them 18, the first one will be 2/18, second will be 6/18, and then that last one will be 3/18, right? So now if you add them all together, 2 plus 6 plus 3, that's 11. So 11 out of 18 is my chance of getting in room A. What about room B? Room B is, room B is 1/9, 1/9, and 1/6. So 1/9, 1/9, 1/6. I can still make them out of 18. It still works, right? 2 out of 18, 2 out of 18, 3 out of 18. So 2 plus 2 is 4, plus 3 is 7, 7 out of 18. And use this as a checkpoint. The 2 of these combined, because you're only going to room A and B, the 2 of these combined, the 2 probabilities combined should equal 1. So check what I have here. 11/18 and 7/18. If you add that up, is that 18/18? Yes. So you have 1. Okay. So what's his chance? What is his chance of getting cheese pretty high? Yes, because his cheese is in room A, and he has 11/18 chance to get into room A. He has more than 50% chance of getting there, so he has a very good chance of getting that cheese, right? If Romeo moves through the maze randomly, how many times out of 100 attempts would you expect him to enter room A? How many times would you expect in room B? Okay, so this is what we did before. We take our probability and multiply by how many attempts, right? So room A is 11 out of 18 times 100. Room B is 7 out of 18 times 100. Right? Okay. No, I do not expect you to do this by hand. So I am going to ask us to go ahead and use our calculator to get 61 times. You don't want to, it's 61.11, but it doesn't really count. There's no decimal tries, right? So 61. And then 7/18 times 100. That gives me 38.8. So we're going to round that to 39 times. So 61 times in room A, 39 times in room B. So again, you see how his chance of getting a cheese is pretty good because he has 61 chance of getting in there. Okay. Okay, so for the next problem, it says to give Romeo the best chance of finding the cheese, which room should the cheese be placed? You really want to find the probability for each room. Now, using this diagram itself is really, really messy. So again, I really suggest you redraw your tree diagram with the probability for each of the branches, right? So here's Romeo. He's standing here, and he has 2 choices. He can go here or here. So he's going branch, branch. So he has 1/2 chance. Then here he has 1, 2, 3. He has 3 options there. So there you're going to go 1, 2, 3. So 1/3, 1/3, 1/3. Okay, that's it for that branch. Over here on the bottom here, you have another branch here. You have 2 choices at that fork. So he's going to the left or he's going to the right. So he has 1/2 and 1/2. Now this 1/2 here goes to room C directly. Same thing here. This one, first one goes to A, this one goes to A, and this one goes to B. So A, B. And last but not least, this last fork here, you have 1, 2, you have 2 choices again. So he's going to go 1, 2, and the first branch will go into B, next one will go to C, 1/2 and 1/2 again. Okay, so you have a couple branches here. So again, you might want to highlight this and make sure you can see each of the branches. I'm going to highlight one just so I can see it. All right, so the first branch will be 1/2 and 1/3, all together making 1/6. The next branch is the same as 1/2 and 1/3, so 1/6 again. And the last one is also 1/6. All right, so then what about the next one? The next branch, B, is 1/2, 1/2, 1/2. So 1/2 times 1/2 times 1/2 is 1/8. The branch below, 1/2, 1/2, 1/2 again is 1/8 as well. And last but not least, this is 1/4. Okay, so now I gotta figure out all the probabilities. I need to figure out the probabilities of every single room. So room A, I have 1/6 plus 1/6, and that's it. Those are the only 2 that goes into room A. So that's easy. That's 2, 6, which is 1/3. All right. Room B, I have 1/6 and 1/8, and I think that's it. Okay, so this is a little bit different because I don't have a really small number to work. Okay, so the common denominator would be 24. So 4 over 24, 3 over 24, that gives me 7 over 24. So that is room B. Room C is 1/8 and 1/4. I'm going to change the second 1/4 to 2/8, so I get 3 over 8. All right. So now this is a little bit tricky, right? How do I compare these? These are all different fractions. Which one is bigger? Okay, so off to the side here, I have, I'm going to change these all to the same denominator so it's easier to work with. 1/3, 7 over 24, 3 over 8. Okay, I'm going to change this to something over 24. So 24, that means you multiply by 8. So this is 8 over 24. And then 24, that means times 3. This is 9 over 24. Wow, so it looks like 3/8 is the best one because that's 9 over 24. So I would say in room C, that's the best chance because it has the highest probability. Okay, so if cheese is room C and Romeo finds cheese 6 out of 10 times, does he seem to be learning? Well, let's see. If he's getting it 6 out of 10 times, 6 out of 10, in decimal terms, that's 0.6. But we were expecting 3 out of 8. In decimal terms, 3 out of 8 is 0.375. Is he doing better than we expected? Yes. So we can assume he's learning or he's cheating somehow, like the smell is coming out, right? So doing better than expected. So learning, or there's a leak in the cheese, right? Whatever you think could be the case, okay? All right, I think that's it for this lesson. So make sure you can come to class ready to do the homework. Okay, that's it, guys.